that was what we've ended with in the last video. Let's continue. So to continue here, that one will be 1 over 2m, and each px is just like, we're gonna substitute with the corresponding partial s, partial q. For q here will equals x and y and z, right? So that means px is nothing more than partial s, partial x squared plus py partial s, partial y squared, and pz is nothing more than partial s, partial z squared, right? And we close this parenthesis plus v. I'll not bother to write down this x, y, and z anymore because to save some more space and time. Okay. So that now in the form of the Hamilton we want to the Hamilton-Jacobi equation. So let's write down the Hamilton-Jacobi equation. To remind you, the Hamilton-Jacobi equation is written in the following form for such systems, right? H as a function of q, partial s, partial q, close the parenthesis plus v. No, that h is including, this v is included in this h here, plus partial s, partial t, and that's will equal 0, right? So to write this down, we write 1 over 2m partial s, partial x squared plus partial s, partial y squared plus partial s, partial z squared. We close the parenthesis plus v plus partial s, partial t, and that's all equals 0. So that was the form of the Hamilton-Jacobi equation for the system Schrodinger picture. And actually, as we can see here, the Hamiltonian of this system is really time independent, right? That one here is time independent. So that means we can write down as in the following form, as w, which is a function of coordinates, and coordinates here is y, x and y and z, minus E, the total energy of the system, times t. So that's the form of the generating function s. What we're gonna do now is just to plug in with this s right here in the above Hamilton-Jacobi equation and see what we'll get. Okay, let's plug in with this s here in the above Hamilton-Jacobi equation. What we're gonna get 1 over 2m partial s, partial x squared. That means partial w, partial x squared, right? Because this part here has a 0 derivative with respect to the space coordinate. Partial w, partial x squared plus partial w, partial y squared plus partial w, partial z squared. So far so good. Plus v minus E, and that's all equal 0, right? Awesome. Now we can just we'll make a simple observation. We can do the partial plus partial that one here, partial w, partial y squared, partial w, partial y squared, partial w, partial z squared. This is not important than the norm squared of the gradient of the function w. That is, we can write down this in the following form: the gradient, the norm squared of the gradient of the function w, right? I'm sure you know about that. Plus v, and that's all equal E. We're just taking E to the opposite side by the opposite direction, by the opposite side. Okay, so that was the last equation. We're just gonna create a new page. Continue here. Okay. So actually, I'm gonna continue in the next video. Thanks for watching.